Hello everyone. In the last session, we discussed about heat, temperature, their units, and how we can measure the temperature and what are the scales of temperature. So in this session, we will be discussing about what are the effects of heat, thermal expansion, then thermal expansion in solids, liquids, and gases. So let's start this session. Effects of heat. Basically, heat is produced mainly the three following effects. Those are change in temperature of the body, change in size or shape of the body, change in state of the body. So let us discuss these three effects one by one. The first one is change in temperature of the body. So what is this? See, we know that when a body is heated, its temperature increases, right? And when it is cooled, its temperature falls, right? So this change in temperature of the body depends mainly on three factors. The first one is the quantity of heat which is imparted or rejected from the body. The second one is the material of the body, and the third is the mass of the body, right? Next type, we have change in size or shape of the body. Like when you heat a body, so what happens? It starts expanding, and when it is cooled down, it starts contracting. So due to this, there is a change of the size in the body due to the heating. So this process is known as thermal expansion. So thermal expansion we will be learning in the next topic in solids, liquids, and gases in detail. Next, the third effect is change in state of the body. So, what is this change in state? See, we know that matter exists in three different states, namely solids, liquids, and gases. So, the process of change from one state to another at a constant temperature is called the change in state. Now, let us understand this change in different states of matter with this diagram. So here children see when you heat a solid, it changes into liquid, right? So this process is called melting or fusion. And the reverse of this, when you cool the liquid, this is known as when the liquid freezes into the solid at the same fixed temperature. So this process is called freezing, right? So solid to liquid, it's melting, and liquid to solid, when it cools down, it is known as freezing. For example, you see ice at 0 degree centigrade on heating melts into water at 0 degree centigrade, while water at 0 degree centigrade on cooling freezes into ice at 0 degree centigrade. That means their states are changing, but the temperature remains constant. Similarly, if you heat a liquid, so what happens? It changes into vapor or gas. So this process is called vaporization or boiling. And the reverse of this, when the vapor is cooled and the vapor condenses into liquid at the same fixed temperature, so this process is called condensation. Okay. So example you see here, when the water at 100 degrees centigrade on heating vaporizes into steam at 100 degrees centigrade, while steam at 100 degrees centigrade on cooling condenses into water at 100 degrees centigrade. So in this case also the temperature is constant, right? Next is when suppose a solid is directly changing into vapor or gas, right? But the temperature is fixed again. So this process is called sublimation. Similarly, the change directly from vapor to solid at a fixed temperature is called deposition. Sometimes it is also known as solidification. Both are same. Okay. So example here, best example you see camphor. We call it as kapoor also. So when you heat the camphor, it changes directly into gaseous state, and when you cool it, it changes from its gaseous state to solid state. Okay. Next, we have the change of state from liquid to gas at all the temperatures. That means the temperature is not constant in this case. Suppose if the liquid is changing to gas at all the temperatures, then that is known as evaporation. So, thus, evaporation is quite different from boiling because boiling is taking place at fixed temperature, whereas evaporation takes place at all the temperatures. For example, you see if you're drying the clothes, so the clothes dries due to the evaporation because evaporation is a very slow process if you compare it with boiling, because boiling is a rapid process. Okay, children. So this is the very important diagram. You need to practice this diagram. Next, we have here some important point. See, whenever there is a change of state at fixed temperature, so what happened? The heat may be rejected or absorbed, but this heat does not change the temperature of the substance. Okay, so there is a specific name given to this heat, that is latent heat. Okay, so about the latent heat, you will be learning in higher grades. So just remember this point. Next, we have thermal expansion. So we know that if we heat a substance, it expands, and when it is cooled, it contracts. So now let's see how does it affects in solids, liquids, and gases. First of all, in solids, we see when a solid is heated, it expands in all the directions. That means length, area, and volume wise. So based on that, they have categorized this. If it increases in length of a solid, it's called linear expansion. The increase in area is called superficial expansion. And if the increase in volume, then it is called cubical expansion. Let us understand this with an activity. See here, you take a piece of iron wire like this as shown in this figure and slip a curtain ring through the wire like this. This is the curtain ring. Stretch the wire between the two vertical stands like this and adjust the position of the stand so that the wire is just tight. That means the wire should not be loose. Now, what you have to do, this is the case when we are not heating the wire. So, before the heating, the wire is tight. In the second case, when we start heating it up, the wire becomes loose. How? Now, let's see. Now, heat the wire over a low flame using a burner, as we can see in this figure. So, what we have noticed that the wire, when it starts heating up, it no longer remains tight, but it becomes loose. See here in this figure. This indicating by the dangling ring. See. So this shows that when you heat the wire, it starts expanding. And when you remove this burner and allow the wire to cool down, so what we will observe that the wire will contract and it becomes tight again. Okay. So this is one of the activity which shows that on heating it expands, the wire expands. Next, one important note you have to keep it in your mind that different solids expands by different amounts for same rise temperature. For example, brass expands 1.5 times more than iron. Temperature remains same, but the expansions are different. Some substance like invar, pyrex glass, etc., they expand negligibly on heating. So these are some exceptional. Okay. Next, we have some applications in our daily life. Let us see how it works on our daily life. Telephone and electric wires, when connected in summer, between two poles, they are kept loose. Why? Because they may not break when they contract in winter. On the other hand, if you see, the wires are connected in winter between the two poles and they are kept tight. The reason is because they can expand in summer and they will not sag. Okay. Second example, you see, children, when you construct a bridge, steel guiders are used, right? So one end of the guider is fixed into the concrete or brick pillars, we can say, and its other end is not fixed, but it is placed on the rollers. What is the reason? Suppose if there is any rise or fall in temperature, the guiders can freely expand or contract without affecting the pillars. So that is the reason they are not fixed at the other end. Okay. Next example, you see the rails of railway track are made of steel. While lying in the railway track, the small gap is left between two successive lengths of the rail. What is the reason here? The reason is that the rail expands during summers, right? And the gap which is provided is just to expand during the summer. And suppose if there is no gap left, then what will happen? The expansion in summer will cause the rails to bend sideways, and because of this, the train accidents may occur. More train accidents can occur. Okay. Next example, we have a cement floor is not laid out in one piece, as you can see, because it would crack due to the expansion in summer, and during the winters it may contract. But on the other hand, if you see the floor laid in small pieces only with some gaps in between them, so that that gap is left because it can expand during summer. And however, you can place some glass strips also in that gaps. Okay, so these are some applications in our daily life. Next, let us see the thermal expansion in liquids. Like solids, liquids also usually expands on heating. Liquids expand much more than solids when heated. Liquids do not have a definite shape, but they have a definite volume. So therefore, liquids have only the cubical expansion, okay, volume wise. So some exceptions are there here. This is very important point, children. Water on heating from 0 degree centigrade to 4 degree centigrade contracts, and after that, if you further heat it, it start expanding. Okay. Next, we have one activity to understand this thermal expansion in liquids. See here in this figure, children, before heating and after heating. So what do you have to do? You take an empty bottle, and it should be tight fitted with some cork, and it should have a hole drilled in its middle only, and a drinking straw should be there. Two bricks you take, and a wire gauge and a burner. Okay, now fill this bottle completely with water and add some few drops of color so that we can see the level of water more clearly. Okay, now place this straw into the cork and put some molten wax around the hole so that there should not be any leakage of water near this mouth of the bottle. Now pour some more water into the drinking water so that the water level in the straw can be seen easily. And then you mark the level of water in the straw as shown in the figure A. In this is the level, first level. Now what you do, children, just try to place this bottle on the wire gauge, which is kept on the two bricks, and start heating it. Okay, by means of a burner. That means you can place a burner below this and start heating this bottle. What you will see, the level of water in the straw rises. See here, this level has been rises up. So this shows that the water also expands, or the liquid also expands on heating. Okay. Next, thermal expansion of gases. So gas also expand when they are heated. Gases expand much more than liquids and solids. Okay, because they do not have definite shape, size, so they also have only the cubical expansion. So let us see this one. Here also you see we have taken bottle before heating and after heating we have. So in this first case, you see, children, you take an empty bottle, and we know that empty bottle contains air. Okay, and you attach a balloon to its neck, rubber balloon, as shown in this figure first. So in this first figure, see, balloon is deflated, right? Now place this bottle into the water bath. I mean, any container which contains water. So here they have given the name water bath, right? And after some times, you will notice that uh, because this water bath, I should say, has some boiling water. Okay. So after some times, what we will notice, that the balloon gets inflated like this. It started inflating, as you can see here in this figure. What is the reason here? The reason is that we know that air is inside the empty bottle. So that air inside the bottle starts expanding on heating, and it starts filling the balloon. Okay. Now what do? You take the bottle out of this water bath and allow this bottle to cool by itself. After that, what you will notice, when it starts cooling down, the balloon gets deflated and it collapses. So the reason is that the in air which is inside the balloon and the bottle, it starts contracting on cooling, and the air from the balloon passes to the bottle. So the bottle so that the balloon gets deflated. Okay, so this also shows that the gas also expands. So this is all for today's session, children. Thank you, all of you.